5, 4, 3, 2, 1, 0.
Hello and welcome to our online classes. Today we are going to explore the fascinating world of gravitation, which is one of the most fundamental forces of nature. From the falling of an apple to the orbit of planets around the sun, gravity plays a vital role in our lives and the universe as a whole. In this video, we will cover various aspects of gravitation, including the laws of motion, circular motion, Kepler's laws, the relationship between G and G, variation of G with height, depth, and latitude, and the difference between mass and weight. We will also delve into topics like free fall and kinematical equations, gravitational potential energy, and escape velocity. So buckle up and get ready to be amazed by the wonders of gravitation. Don't forget to like, share, and subscribe to our channel and leave your comments down below. Let's begin. Gravity is the force that pulls objects towards each other. It is what keeps planets in orbit around the sun and objects on Earth's surface from flying off into space. In this chapter, we will explore some of the fundamental concepts related to gravitation. 1. Newton and the apple. Isaac Newton, a famous physicist, discovered the law of universal gravitation when he saw an apple fall from a tree. He realized that a force, which we now call gravity, pulls objects towards each other. This is why the apple fell towards the ground and not away from it. 2. Circular motion and centripetal force. When an object moves in a circle, it experiences a force called the centripetal force. This force is directed towards the center of the circle and keeps the object moving in a circular path. For example, when you swing a ball on a string, the string provides the centripetal force that keeps the ball moving in a circle. 3. Kepler's laws. Johannes Kepler was a famous astronomer who discovered 3 laws that describe how planets move around the sun. His first law states that planets move in ellipses around the sun. His second law states that a planet moves faster when it is closer to the sun and slower when it is farther away. His third law states that the time it takes for a planet to orbit the sun is related to its distance from the sun. For instance, Mercury, the closest planet to the sun, moves at a faster speed than Neptune, which is much farther away. This is because of Kepler's second law. 4. Newton's laws of motion and law of gravitation. Newton's 3 laws of motion describe how objects move when a force is applied to them. His law of gravitation states that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This means that the larger the masses of the objects and the closer they are to each other, the stronger the force of gravity between them. One example is how the moon orbits around the Earth due to the force of gravity. The Earth's mass is much larger than the moon's, so it exerts a stronger gravitational pull on the moon, keeping it in orbit. 5. Relation between G and G. G is the gravitational constant, a number that relates the strength of gravity to the masses and distances of the objects involved. G is the acceleration due to gravity on Earth's surface, which is about 9.81 meters per second squared, meter per second squared. The value of G is what determines the strength of gravity between any two objects in the universe. 6. Variation of G with height, depth, and latitude. The acceleration due to gravity, G, varies with height, depth, and latitude. At higher altitudes, G decreases slightly because there is less mass between the object and the center of the Earth. At greater depths, G decreases slightly because there is less mass between the object and the center of the Earth. G also varies slightly with latitude because the Earth is not a perfect sphere and is slightly flattened at the poles. For example, the acceleration due to gravity at the equator is about 9.78 meters per square second, while at the poles it is about 9.83 meters per square second. For example, a person would weigh slightly less at the top of a mountain than they would at sea level because the acceleration due to gravity is slightly less at higher altitudes. Difference between mass and weight. Mass is a measure of the amount of matter in an object and is usually measured in kilograms, kilogram. Weight is a measure of the force of gravity acting on an object and is usually measured in newtons, N. Mass is the same everywhere, but weight depends on the strength of gravity. For example, an object that has a mass of 10 kilograms would weigh 98 N on Earth, but only 38 N on Mars, where the strength of gravity is weaker. 1. Free fall and kinematic equations. When an object falls freely under gravity, it is said to be in free fall. The acceleration due to gravity is denoted by g, and is approximately 9.81 meters per square second on Earth's surface. The kinematic equations can be used to calculate the motion of objects in free fall. For example, if an object is dropped from a height of 10 meters, we can calculate how long it will take to reach the ground using the kinematic equation, d equals 1/2 gt squared. 2. Gravitational potential energy. Gravitational potential energy is the energy possessed by an object due to its position in a gravitational field. It is defined as the amount of work required to lift an object to a certain height against gravity. The formula for gravitational potential energy is P equals mgh, where m is the mass of the object, g is the acceleration due to gravity, and h is the height of the object above some reference point. For example, the gravitational potential energy of an object on the surface of the Earth is given by P equals mgh, where h is the distance from the object to the center of the Earth. 3. Escape velocity. Escape velocity is the minimum velocity required for an object to escape the gravitational pull of a planet or a celestial body. It is given by the formula V equals square root of 2gm r, where g is the gravitational constant, m is the mass of the planet or celestial body, and r is the distance from the center of the planet or celestial body to the object. For example, the escape velocity from Earth's surface is about 11.2 km per second, which means that an object must be launched from Earth at a speed of at least 11.2 km per second to escape its gravitational pull and travel into space. In conclusion, gravitation is a fundamental force that governs the behavior of objects in the universe. It is responsible for keeping planets in orbit around the Sun, causing objects to fall towards the ground, and even determining the shape of galaxies. We have discussed several key concepts related to gravitation, including Newton's laws of motion and gravitation, Kepler's laws, the relation between g and g, and the variation of g with height, depth, and latitude. We have also discussed free fall and kinematic equations, gravitational potential energy, and escape velocity, which are important concepts in understanding how objects move in the presence of gravity. Here are 10 unique facts about gravity in the world. 1. The force of gravity is responsible for keeping the moon in orbit around the Earth. 2. Gravity is the reason why we can stand on the surface of the Earth. 3. The gravity of the Sun is what keeps all the planets in our solar system in orbit around it. 4. The force of gravity between two objects decreases as the distance between them increases. 5. The gravity of a black hole is so strong that it can even trap light. 6. The gravity of Jupiter is so strong that it can cause comets to change their trajectory. 7. The gravity of Earth is slightly stronger at the poles than at the equator because the Earth is not a perfect